So, you are Ioannis Paschalidis, chemistry professor at the University of Cyprus, a scientist and a researcher. Tell us, how do you differ from theoretical scientists?
Usually, theoretical scientists create, whereas we discover, and we discover nature itself.
What's the objective of your research?
In this laboratory, we deal mostly with the identification of radioactive and toxic pollutants in the environment. It's important to know the pattern in which these pollutants appear. The pattern is very important since this is what determines their dispersal rate, the rhythm of their dispersal rate, as well as their degree of toxicity, how toxic they are towards humans and other organisms.
What we see in old mines, is that an example of pollutant dispersal in the environment?
Yes, one can say that that is dispersal of pollutants and pollution of the water table. In just this case, as the bedrock is dilapidated, the rate of leaching of pollutants is greater, thus the bright array of colors.
What other substances do you study in your lab?
At this time, we're dealing mainly with the detection and identification of uranium and radon in natural water systems. Radon is a radioactive, very inert gas which is produced naturally from radium and is found on rock strata. Being a gas, when produced, it can easily rise through the rock. If it ends up in concentrated amounts in enclosed spaces occupied by humans, it can present problems. In case it doesn't escape, it remains in the rock where it decomposes without any problems.
You said that radon is a gas which creates problems if it concentrates in enclosed spaces. How come you study its presence in water?
Radon is slightly soluble in water. Its presence in water indicates that these water bodies are in contact with rocks containing naturally occurring radionuclides, like uranium and radium. On the other hand, it has been observed that detection of high concentrations of uranium in natural water reservoirs is followed, usually, by earthquakes. A continuous recording of the concentration of radon in natural springs or water systems could be then used as a warning for oncoming earthquakes. We measure the concentration of radon in two different ways. The first thing is to calibrate the instruments. We have here some minerals for which we know how much radon they produce. We allow these to come to equilibrium, and then we use them to calibrate the devices. Well, after calibration, we start measuring the concentration in natural waters using our calibrate. One way is directly in the water sample with the aerification of radon, and the other is with infusion. The research we do here mainly belongs to the area of radioanalytic environmental chemistry. Its main characteristic is that we attempt to discover the patterns of these substances in environmental systems and the way they interact with them.
You keep going on after your everyday research at work. in the same modus vivendi in your spare time too?
Well, yes, this is quite true, actually. I keep myself busy making mosaics. As you see here, I use old tiles, which I've broken into pieces, to create a pattern. But I also like to make mosaics with small pebbles. And I find these pebbles here on the mountains. There's an abundance of pebbles with different colors which can be used to make colorful mosaics.
What are your favorite subjects?
Right now I'm making the logo of the University of Cyprus, which I may give as a present to a friend. Otherwise, I like patterns with grapes a lot, landscapes, the sea.
Research is the food of mind, but art is the food of the soul. Somehow, we must exercise in some way the rest of our body too. Ioannis Paschalidis and daughter in action.